my former postdoc Jason Stumpff is doing. I know. I'll give him a call.
I bet that's Linda Wordeman from the University of Washington. Hello.
Hi Jason, how's it going?
What's up, Linda? How are you?
How's life as an assistant professor?
It's actually great. There's lots of exciting research being done here.
Sure is a long ways from Seattle though.
Yeah, and you know, I've had a little bit of trouble here in the lab. My new rev code did melt down, and my lab flooded over Christmas. And someone dumped an entire bottle of oil into the nose piece of my microscope. But otherwise, it's been great.
Well, at least your new study on the forces guiding chromosomes to the spindle midzone is published.
Yeah, we always suspected that the highly processive kinesin KIF18A might suppress microtubule dynamics once it reached a threshold concentration on the kinetochore fiber to restrict the movement of chromosomes out of the midzone, didn't we?
Yeah, it's a cool mechanism in that the chromosomes can use a bunch of different ways to get to the spindle midzone, but once they get there, KIF18A keeps them there.
And the chromokinesin KID always seemed like a great candidate to guide chromosomes to the midzone because it's a plus-in directed motor sitting right there on the chromosome arms.
Yeah, it was pretty sweet when you found that knocking out both KIF18A and KID at the same time removed all positional information from the spindle, leaving the chromosomes to wander in a completely random manner all over the spindle.
Yeah, that was pretty sweet.
But we had to test KIF4A as well, because it's also a plus-N directed motor on the chromosome arms.
True. It sure seemed like it was going to be redundant plus-in directed force guiding chromosomes to the midzone.
Man, the joke was really on us on that one, huh?
Yeah, who knew that KIF4A would actually inhibit the movement of chromosomes to the midzone?
Yep. Figuring out how two plus-N directed motors on chromosome arms could have an opposite effect on chromosome congression to the midzone sure took us some time to figure out.
Uh-huh. We had some guidance from the literature there, though, especially from Tom Surrey's lab in London, and their previous work on the XKLP1 and XKID orthologs in Xenopus.
Very true. We stood upon the shoulders of giants on that one.
Ah, you said it.
We were able to make a few judicious mutations and drive those chromokinesins into the cytoplasm and show that KID is, in fact, a plus-N directed motor through and through, while KIF4A actually restricts microtubule length and only uses its plus-N directed activity to get to the microtubule end.
Yeah, that was awesome. And that turns out to be the way that KIF4A suppresses chromosome congression by limiting microtubule length in the spindle midzone, so KID doesn't have as much of a substrate to translocate on.
Cool. And furthermore, I bet it's a bad idea to have too many long microtubules crossing the spindle midzone during metaphase.
Yeah, that would fit with your former graduate student Sarah Dominance's paper showing long microtubules compromise kinetochore attachment. And that's coming out in JCB soon, right?
Yep. But, you know, perhaps the coolest thing about your paper is what happens to the regulation of directional switching at the kinetochore when the cells are forced to congress without the help of KIF18A, using only the chromokinesin KID alone.
You mean where we showed that kinetochores can switch to KID-dependent, tension-dependent, positional control of directional reversal in the absence of KIF18A?
Yeah, I hope people don't miss that when they read the paper.
Uh-oh! I think something just exploded in my lab.
Okay, better check that out. It was great talking to you.
Okay, I'll see you at the next meeting. Gotta go. Bye.
Bye-bye.